All right, in this video, I'm going to be showing you about the method of variation of parameters. And this is probably going to be the last of the techniques for second order linear ODEs that I'm going to show you. And this one is, well, it's kind of like the method of undetermined coefficients, except, well, if you look at this thing, we'd have to express this as a quotient using sine and cosine. And that's not going to go so well if you were to try to use the method of undetermined coefficients. So much like, when I showed you a few videos ago about the method of reduction of order, I'm going to start with this example and then be like, okay, what did we just do here? Okay, so I know how to solve the corresponding homogeneous equation, right? I can say that y double prime plus 4y equals 0 gives me the characteristic polynomial r squared plus 4 equals 0. That gives me r equals 0 plus or minus 2i, which means that, my homogeneous solution is like y1 is c1, hold on, cosine of 2t plus c2 times the sine of 2t, right? And so the idea here is that we're going to let c1 and c2, no, y homogeneous. Yeah. I was going to write them separately, but I think actually this will be better. So the real solution that has the solution of the homogeneous and the part that makes it not homogeneous is going to be where we're going to think about letting our parameters vary, okay? Which would be basically, what if c1 and c2, instead of being a number, were a function of t? Could we potentially find a solution? And the answer is yes, we will be able to. So I'm going to say actually, and maybe this is big enough of an idea that I'll write it in a different color. That the solution y is going to be u1 of t times cosine of 2t plus u2 of t times the sine of 2t. Okay? And let's see, what am I going to say from here? I think I'm just going to take the derivative of this thing. Yeah. Okay. And so I'll switch over here. And we're going to really just start basically taking derivatives. I'm going to need to impose a couple of conditions on it to make sure that we have just like a good solid way to find a solution. And then we'll just kind of, after making some assumptions, answer is going to fall out. So what I'm going to do is I'm going to say y prime is going to be, all right, I need to take the derivative of this, but I'm going to do this in such a way that I leave the u1 prime and the u2 prime off to the very end. Okay? So y prime is going to be, and I think I'm going to stop calling it u1 and u2 of t because it's just going to get way too noisy and I'd fill up everything and wouldn't be able to show you what I had been doing as I was moving forward. So I'm going to be calling it negative 2u1 sine 2t plus, and I know there's product rule, I'm going to deal with u1 prime at the back, plus 2u2 cosine of 2t. Then I'm going to have plus, well, maybe I will write it here, plus u1 prime cosine of 2t plus u2 prime sine of 2t. I'm going to take a step back and make sure that I have done that product rule correctly. Yeah, okay, this looks good. Now, I'm going to say that, and you don't really have any reason to think about why I would want this. I think you'll see that it's going to make it work out much simpler, and it will still work out, that I'm going to ask that this be 0. And basically, there's enough free variables, enough freedom in this expression here for me to choose a u1 and u2 that are going to satisfy this. Okay, so I'm going to, how did I write this? Okay, so pretty much I was calling cosine of 2t and sine of 2t, y1 and y2 respectively. And yeah, moving forward, I'm going to let y1 and y2 be the solutions to the corresponding homogeneous equation. And then when I show you what happened in general, I'll be using kind of the same language. All right, so I want to choose u1 prime y1 plus u2 prime y2 equals 0. That's going to be the first condition. Meaning that y prime is just going to be this piece right here that I have not boxed in pink. So yeah, maybe I'll just go over here and just to kind of recap, y is going to be u1 y1 plus u2 y2. So u1 cosine 2t plus u2 sine of 2t. Y prime now, after I've imposed my condition, is going to be negative 2u1 sine of 2t plus 2u2 cosine of 2t, and y double prime, okay, I can take that derivative. It's going to involve the product rule. It's going to be a little long, but it'll be all right. And let me see, how did I write this? Did I collect them all together in some sensible way? No, I actually did do that. Okay. Okay, so I said negative 4u1 cosine 2t minus 4u2 sine 2t I'll need the u1 prime and the u2 prime. I'll have negative 2u1 prime sine of 2t, right? Because I'm just going to take the derivative of this and leave that the same. Okay. Oh, realize. How far can I go? Can I go that far? Okay. So plus, oh no, I guess it'll be minus 2u1 sine, u1 prime sine of 2t plus 2u2 prime cosine 2t. And now I'm going to plug these three things back into this equation. Okay? And now I'm really fortunate right now because I only have a y double prime and a y, but there could be problems where we would need all three of these, right, to plug back into the original non-homogeneous differential equation. So, all right, I'm going to just get in at that and say, all right, and I may have to start abbreviating, let's see, is that what I did? Yeah, I'm going to have to start abbreviating cosine of 2t and sine of 2t with like a capital C and capital S, because otherwise I'm just not going to have enough room here to show you. So, going back to the original equation, I've got y double prime is negative 4u1 cosine of 2t minus 4u2 sine of 2t minus 2u1 prime sine of 2t plus 2u2 prime cosine 2t plus 4y. So that's plus 4 times, I'm going to have to rotate this a little bit. That'll do for now. Plus 4 times y, which is u1 cosine of 2t plus u2 sine of 2t. And that's equal to, what was it, 3 cosecant of t. Yeah, barely still in there. Now, some stuff is going to have to cancel here, right? That's basically the consequence of choosing this that way. And the fact that cosine of 2t and sine of 2t are solutions to the homogeneous equation is actually, I think, what's killing these off. But anyway, I've got this negative 4u1 cosine, and then I'm going to add back 4u1 cosines. Okay, I got negative 4u2 sine of 2t, positive 4u2 sine of 2t. And so I'm just left with these things. Okay. And make sure I've got that right. Yep, negative 2u1 prime. So now, negative 2u1 prime sine of 2t plus 2u2 prime cosine of 2t is equal to 3 cosecant t. All right. But I also know that, back to my initial my condition I put on in the first place, the condition I put on my solution, is that u1 prime, y1 was cosine 2t, plus u2 prime sine of 2t need t equals 0. Okay. And this is pretty much something that is like algebraic and can be solved for u1 prime and u2 prime, and then of course we can go and anti-differentiate to find u1 and u2 and then attach them to y1 and y2 and we'll have ourselves a solution. But actually doing that can be oftentimes tricky in practice. So I will start by, I think I'm going to solve for u2 prime here. Which, I mean, you could start going any direction you wanted. But yeah, I'll just start by solving for u2 prime. So u2 prime is going to be equal to, I will subtract this away, so I'll have a negative u1 prime times cosine of 2t divided by sine of 2t. Right? And then I'm going to use this formula for u2 right here in this other equation. So basically I'm using substitution to solve the system. So, all right, I've got negative 2u1 prime sine of 2t plus 2 times this. So 2 times, and I'm going to substitute this whole thing right there. So I'll have negative 2u1 prime times this fraction and still multiplied by cosine 2t. And that's equal to 3 cosecant t. And you may think that there's very little hope of solving this, but actually it's looking pretty good at this point because I'm going to, what am I going to do? I'm going to start by multiplying both sides of this equation by sine of 2t. Okay? And then what's going to happen is I'm going to have, okay, I'll factor out a negative 2u1 prime. And what am I going to be left with here when I multiply both sides by sine of 2t? Here I'll have a sine squared 2t. Here I'll have 2 powers of cosine 2t, which is going to be sine squared 2t plus cosine squared 2t, which is going to be 1. And then that's equal to 3 times the cosecant of t times that sine of 2t. Make sure, is that where I was? Yeah, hold on. Cosecant t. Oh, yes, and of course, yeah, okay, I see what I'm supposed to do. I'm supposed to know my trig identity here. And so I think I'm going to need more space, and I don't really want to erase this quite yet. So I think I'm just going to like pick you up and move you real quick. All right, yeah, so let's jump in and do some trig identities here. So negative, well, maybe I'll just solve for u1 prime. And that's going to be negative 3/2 times cosecant t, which is 1 over sine t, times sine of 2t. And sine of 2t is 2 times the sine of t times the cosine of t. Okay, so I've basically got that u1 prime is equal to -3 cosine of t. Now, from here, we can definitely go in and say we know what u1 is going to be now, right? And is that, okay, that's what I need. But really what I need is I need to go back to this one and get u2 prime, right? And then I can find u1 and u2 at the end. So I'll say that u2 prime is going to be negative of u1 prime, so negative of -3 cosine t, so 3 cosine of t, and then multiplied by cosine of 2t divided by sine of 2t. All right, this is going to require more trig identities, more double angle identities. All right, cosine of 2t, we can say that that's cosine squared t minus sine squared of 2t. That's actually not going to help me. I want it just in terms of sine. Wait, no. I think I said that wrong. Cosine squared t minus sine squared t, which is going to be the same as 1 minus 2 sine squared t. So this is equal to 3 times the cosine of t times cosine of 2t. I'm going to use 1 minus sine of 2 sine squared t. Goodness. All right. I did it at one point, know my trig identities. And then I'm going to divide by sine of 2t, which is 2 times the sine of t times the cosine of t. And then I'm going to cancel off the cosines, and I will have, okay, what am I going to have? I could say that's going to be 3/2 of 1 over sine t, so that's cosecant t. And then minus, well, 2 times 3/2 would be 3, so minus 3, and this is sine squared t divided by sine of t is going to be sine of t. And so I've got u2 prime. All right. Well, I'll deal with the easy one first, right? u1 is going to be the antiderivative of -3 cosine t with respect to t, which means that u1 is -3 sine t. I suppose plus c1. Okay. And then u2 is going to be, and you're going to say, how do I take the antiderivative of cosecant? Well, really what you're going to do is, I don't remember exactly how you show it, but it's not impossible. It's doable using maybe some trig substitution. I don't know, maybe integration by parts. I don't remember. But it's also something you can just look up in a table of integrals. And the antiderivative of cosecant of t is the natural log of the absolute value of cosecant t minus cotangent t. So that's 3/2 log absolute value of cosecant t, I've already forgotten, is it minus? Yes, minus cotangent t. And then, well, there's this -3 sine t, so it'd be plus 3 cosine t plus c2. I don't know. Yeah, you can see that. All right, and I've got myself u1 and u2, meaning that my solution, my general solution, is y is equal to u1 times, you can't see it back over there, but in orange I had written y equals, let's see, maybe I'll just rotate it, it's kind of risky, up there, y equals u1 cosine of 2t plus u2 times sine of 2t. So, coming back over here, I'll have y equals u1 is -3 times sine of t plus c1. I'm not going to have enough room, so I'm just going to call it u1 cosine 2t plus u2 times sine of 2t. And since u1 and u2 have the constants of integration kind of built in, that will take care of that. Okay? So this is me finding the general solution to that differential equation, y double prime plus 4y equals 3 cosecant of t. But like, what just happened here? Okay, this was like a whole lot of trig substituting, trig identities, and it's like kind of a wild ride, and it's like, is this going to be applicable to other situations? And of course, yes, it is. So let me go clear this all out and start back over. All right, so what just happened here? What we did was we started with a linear second order ODE. Okay, so something like, what we call y double prime plus p of t y prime plus q of t y equals g of t. And then we said, well, suppose that we know solutions to the corresponding homogeneous equation. Okay, so So suppose we have two solutions to the corresponding homogeneous, y1 and y2. Okay, that means that for y1 and y2, y double prime plus py prime plus qy is equal to 0. But the thing is, we only really have the techniques to solve this when p and q are constants. So for our discussion, we're going to need p and q to be constant, but that is not true in general. There are non-constant coefficient linear second order ODEs that are solvable. We just haven't done that yet. And we're probably not going to do that in this particular series, but it can be done. So just suppose we got two of them, and they solve that. We're going to kind of guess that our particular solution is going to be expecting solution y equals u1 of t times y1 plus u2 of t times y2. Or y1 and y2 are both also functions of t. As I said up there, I just didn't have room. So that means that I can take the derivative of y and then the second derivative of y and then, get some stuff to happen over here. So this means that y prime is going to be u1 y1 prime. And again, just like before, I know that there's product rule. I know there's going to be u1 prime y1. I'm going to save that till the end. Okay. And u1 y1 prime plus u2 y2 prime plus then for the other parts of the product rule, I'm going to have u1 prime y1 plus u2 prime y2. And then what I decided was I need this to be 0. And didn't keep us from finding a solution in the end, and in general not going to. So I'm going to impose the condition number 1, u1 prime y1 plus u2 prime y2 needs to equal 0. And then that meant that y, I don't know why I put the prime there, y prime is going to be u1 y1 prime plus u2 y2 prime. All right, meaning I can take the second derivative, okay, and I'll do that, and is u1 prime y1 prime plus u1 y1 double prime plus u2 prime y2 prime plus u2 y2 double prime. And then I take this y double prime, this y prime, and that y, and I put them back into the original equation. Okay. So y double prime is u1 prime y1 prime okay, that's y double prime, I copied down, plus py prime, And again, this is times, not of. Okay, so P times y prime, which is U1, Y1 prime, plus U2, Y2 prime. Okay, not going to have enough room here. So let's see. Need to have Q times, Q times Y, which is U1, Y1 plus U2, Y2. And again, I'm gonna just kind of slide it, give myself a little more room. Q times U1, Y1 plus U2, Y2. That's equal to G of T. And you still can't see it. Okay, I just need some long equations for this. All right, now I'm going to start collecting stuff together. Okay, I'm going to collect everything with a U1 first. Okay, U1, regular U1, not U1 prime. So I've got a U1, and I'm left with, what do I have? I've got a Y double prime here, Y1 double prime. And so what I'm going to do is I'm going to also, as I'm dealing with these terms in this equation up here, I'm going to strike through them so that I know that I've got everything, because I need to collect and rearrange these things. And so I wouldn't want to forget anything. U1, Y1 double prime. U1 right here times P Y1 prime. And then over here I've got a U1 here, so I'll have, if I factor it out, I'll have a Q and a Y1 left. And then if I go and find all the things with a U2 in them, that would be, wait, no, U2 regular is going to be Y2 double prime plus P times Y2 prime plus Q Y2, once I factor out the U2. And, all right, wait, I said I was going to strike through these things, and I just didn't. Okay, so Q, right, then U2, Y double prime, PY prime, and QY. So I'm left with these two things. So plus U1 prime, Y1 prime, plus U2 prime, Y2 prime, and that's also equal to G. But if you look over here, if we know that Y1 and Y2 solve this, then it must be the case that this and this equals 0, right? So really what I've got is 0 plus all this equals G, and I can copy that much easier, right? I can have it more condensed. So U1 prime, Y1 prime, plus U2 prime, Y2 prime needs to equal G of T. And that's going to be condition number 2. And that's, yeah. And then what we do from there, and there's more I could tell you about this, but I didn't tell you a ways back about the Wronskian matrix. That was a mistake. So up to the tools we have, what we're going to do is be pretty much left to fend for ourselves to solve the system imposed by my two conditions. So that would be U1 prime Y1, U2 prime Y2 equals 0. And what would it be? U1 prime Y1 prime plus U2 prime Y2 prime is equal to G of T. Okay, solve the system for u1 prime and u2 prime, get yourself your u1 and u2, go back over here to y equals u1 of t times y1 plus u2 of t times y2, and get yourself a general solution. This is the method of variation of parameters.